Good morning, all of you. Myself, Vesha from ICT EK3, Marwadi University. Today's topic is modulation and multiplexing. And here is the contents of this chapter. Introduction. Next, analog modulation in AM types and in digital modulation and advanced modulation. Next, spread spectrum. And here is a multiplexing introduction. In the multiplexing, there are FDM and WDM and TDM types, and in TDM types of CDMA. And next one, advanced multiple axis, and here is applications, and final is the conclusion. First one, introduction. Modern communication systems must send information long over distance efficiently. And a modulation varies a high frequency carrier signal according to the message signal. And multiplexing combines multiple signals to share a single communication channel. Together, they improve range, bandwidth, utilization, and reliability. Without these two, long distance communication would be slow, expensive, and impossible. And next, here is the analog modulation. In the analog modulation is used when the message signal is continuous. A carrier signal's parameters is varied in proportion to the analog message. Types depends on carrier parameters is changed with the amplitude and the frequency and the phase. And here is the modulation types. AM modulation types. AM has a different types depends on bandwidth usage. Here is a DSP, DSPFC, carrier plus both sidebands. DSPSC, carrier suppressed carrier. SSB, only one sided highly bandwidth efficiency. VSB is a vestigial sideband used in the TV broadcasting. These variations improve efficiency depending on applications, and this is used in a radio broadcasting and TV. And next, FM and PM. Both are analog modulation techniques. FM uses frequency changes to transmit information. It offers great noise immunity compared to AM. And here is frequency modulation. Carrier frequency varies the message amplitude, high noise immunity, and used in FM radio. And here is the PM is a similar but modifies phase. FM and PM are related but differ in how the information alters the carrier. Used in digital system and satellite communication. And next, here is the digital modulation. Digital modulation transmits binary data zeros and ones. Major schemes include ASK, FSK, PSK, and QEM. QEM is nothing but quadrature amplitude modulation. These are essential in modern wireless networks, Bluetooth, and modems. And here is the advanced modulation. As we move toward higher data rates, we know more efficient schemes. Is a 16 QEM and 64 QEM and 256 QEM. And here is the OFDM divides the data into many subcarriers, making communication robust and high speed. OFDM is used in Wi-Fi, LTE, and 5G. OFDM is nothing but orthogonal frequency division multiplexing. And here is the spread spectrum. Spread spectrum spreads data over wide bandwidth. Here is the two types of spread spectrum. Here D triplets direct sequence used in Wi-Fi, FHSS frequency hopping used in Bluetooth. These techniques improve security and reduce interference. And here is the multiplexing introduction. Multiplexing allows a multiple users or signals to share the same communication medium, improving channel utilization and bandwidth and reduces cost. Let's see the main types of multiplexing. There is a FDM and WDM. FDM is nothing but frequency division multiplexing, and WDM is nothing but wavelength division multiplexing. In frequency division multiplexing, each user gets a different frequency band. Example, radio channels like 93.5 FM and 98.3 FM. In WDM, different light wavelengths carry multiple signals through a optical fiber. In WDM and CWDM make fiber communication extremely highly spread. And here is the TDM types. Here is TDM is nothing but time division multiplexing. Signal shares the same channel but transmit in different time slots. Here's the types. Synchronous TDM. Synchronous TDM is nothing but fixed time slot. Here is a statical TDM. Statical is nothing but slots assigned dynamically are more efficient. TDM is widely used in digital telephone networks. And here is the CDMA. CDMA is nothing but code division multiple axes. All users share the same frequency and time. Each user has a unique code, high capacity and security. This technique was heavily used in 3G networks. And here is the advanced multiple axis used in modern cellular systems. In OFDMA alerts OFDM subcarriers to a different users used in 4G and 5G. NOMA shares the frequency using different power levels and uses SIC to separate users. The NOMA is a non-orthogonal multiple axis of 5G. And MIMO uses multiple antennas to improve speed and reliability. And here is the applications. This technology enables mobile communication 2G to 5G and satellite communication, radio and broadcasting, TV broadcasting, Wi-Fi and Bluetooth, optical fiber networks, and IoT systems. Everything around us uses modulation and multiplexing. And here is the final one conclusion. Modulation enables efficient long distance transmission, while multiplexing enables multiple users to share resources. And advanced modulation and multiple axis techniques from a backbone of a modern high speed wireless and optical communication system. Thank you.